TCP/IP protocol suite. The TCP/IP protocol suite was developed prior to the OSI model. Therefore, the layers in the TCP/IP protocol suite do not exactly match those in the OSI model. The original TCP/IP protocol suite was defined as having four layers: host to network, internet, transport, and application. However, when TCP/IP is compared to OSI, we can say that the host to network layer is equivalent to the combination of physical and data link layer. The network layer is equivalent to the network layer, and the application layer is roughly doing the job of the session, presentation, and application layers, with the transport layer in TCP/IP taking care of parts of the duties of the session layer. So in this book, we assume that the TCP/IP protocol suite is made of 5 layers: physical, data link, network, transport, and application. The first 4 layers provide physical standards, network interfaces, internet working, and transport functions that corresponds to the first 4 layers of the OSI model. The 3 topmost layers in the OSI model, however, are represented in TCP/IP by a single layer called the application layer. TCP/IP model. TCP/IP is a hierarchy protocol made up of interactive modules, each of which provides a specific functionality. However, the modules are not necessarily interdependent, whereas the OSI model specifies which functions belong to each of its layers. The layers of the TCP/IP protocol suite contain relatively independent protocols that can be mixed and matched depending on the needs of the systems. The term hierarchical means that each upper level protocol is supported by one or more lower level protocols. At the transport layer, TCP/IP defines 3 protocols: transmission control protocol, user datagram protocol, and stream control transmission protocol. At the network layer, the main protocol defined by TCP/IP is the internetworking protocol. There are also some other protocols that supports data movement in the layer. Physical and data link layers. At the physical and data link layer, TCP/IP doesn't define any specific protocol. It supports all the standard and proprietary protocols. A network in a TCP/IP internet network can be local area network or a wide area network. Network layer. At the network layer, or more accurately the interwork layer, the TCP/IP supports the internet working protocol. IP in return uses 4 supporting protocols: ARP, RARP, ICMP, and IGMP. Each of these protocols is described in greater detail in later. Internet Working Protocol. The Internet Working Protocol is the transmission mechanism used by the TCP/IP protocols. It is an unreliable and connectionless protocol, a best effort delivery service. The term best effort means that IP provides no error checking or tracking. IP assumes the unreliability of the underlying layers and does its best to get a transmission through to its destination, but with no guarantees. IP transports data in packets called datagrams, each of which is transported separately. Datagrams can travel along different routes and can arrive out of sequence or be duplicated. IP does not keep track of the router and has no facility for reordering datagrams occur they arrive at their destination. The limited functionality of IP should not be considered a weakness. However, IP provides bare-bones transmission functions that free the user to add only those facilities necessary for a given application and thereby allows the maximum efficiency. Address Resolution Protocol. The Address Resolution Protocol is ARP is used to associate a logical address with a physical address. On a typical physical network such as LAN, each device on a link is identified by a physical or station address, usually imprinted on the network interface card. ARP is used to find the physical address of the node when the internet address is known. Reverse Address Resolution Protocol. The Reverse Address Resolution Protocol (RARP) allows a host to discover its internet address when it knows only its physical address. It is used when a computer is connected to a network for the first time and when diskless computer is booted. Internet Control Message Protocol (ICMP) is a mechanism used by the host and gateways to send notification of datagram problems back to the sender. ICMP sends query and error reporting messages. Internet Group Message Protocol (IGMP) is used to facilitate and simultaneous transmission of a message to a group of recipients. Transport Layer. Traditionally, the transport layer was represented in TCP/IP by two protocols, TCP and UDP. IP is a host-to-host protocol, meaning that it can deliver a packet from one physical device to another. UDP and TCP are transport layer level protocols responsible for delivery of a message from a process to another process. A new transport layer protocol (SCTP) has been devised to meet the needs of some newer applications. User Datagram Protocol. The User Datagram Protocol is a similar of the two standard TCP/IP transport protocols. It is process-to-process control that adds only port addresses, checksum error, and length information to the data from the upper layer. Transmission Control Protocol. The Transmission Control Protocol provides full transmission layer services to application. TCP is a reliable upstream transport protocol. The term stream in this context means connection oriented. A connection must be established between both ends of a transmission before either can transmit data. At the sending end of each transmission, TCP divides a stream of data into smaller units called segments. Each segment includes a sequence number for reordering after receipt together with an acknowledgement number of the segments received. Segments are carried across the internet inside of IP datagrams. At the receiving end, TCP collects each datagram as it comes in and reorders the transmission based on sequence numbers. Stream Control Transmission Protocol. The Stream Control Transmission Protocol provides the support for newer applications such as voice over the network. It is transport layer protocol that combines the best features of UDP and TCP. Application layer. The application layer in TCP/IP equivalent to the combined session presentation and application layer in the OSI model. Many protocols are defined in this layer. We cover many of the standard protocols in later chapters.